Right, I'm doing this again because I've found almost everything, I believe. Here we go, the three puzzles of the three threes. In the beginning, there was this circle which was discovered by Alan Green, and it runs from this very large G dot to this imprinted dot, which is roughly half the area of this for some reason. Now, there are three triangles on here. On the first relates to pi. Its tangent value is pi. And what that means is if I put a circle on here, the circumference of that circle is equal to the long line, which means that if I roll that circle down that hill, when it gets there, it'll have turned 360 degrees. Now, the second one was known at this time in history as the gold of mathematics, and that's a Pythagorean triangle. 3, 4, and 5 are the relative lengths of its sides. Now, the third of these three triangles, or only three, is indicative of phi, in that the short yellow line forms a divine portion, a golden ratio, with the short green line. And what that means is if we put a pentagram, for instance, on there, we're going to be using pentagrams later, then it turns out that this short yellow line is exactly that length. That's good. So that's the basis. Now I need to now show you 5 construction lines. This is the first one. Horizontal line from the G dot goes through those 2 T dots and will terminate it on the circle. Now, if we then draw another construction line from the 9 dot, from the phi triangle to the pi triangle, where that intersects the red line is where that second T dot should go. I've got 2 more construction lines. This one is a tangent from G. It's perpendicular to that diameter. And then there's this chord from the 9 dot, which is parallel to that, and intersects this line, which begins at the pi triangle. So that upper rule is now defined, but we don't know how high this one is because it doesn't have a triangle on this side, and we're going to terminate it by drawing a construction line onto there. And there it is, and that's the final construction line. That's the end, and that defines this point, and there. So it's a horizontal line which is terminated by the circle. Now, the point about that, beginning and end. This is the beginning. Everything on this page in principle is derived, absolutely everything, from this line, and then this for our first puzzle is the ending line, the last line that you can draw. You have to draw all the other ones before you can get to this. Now, the gig about that is, why do you go at London? So this is the mathematically predicted line. That's actually where this upper rule ends, and I'll come to that anomaly in a moment. But if we draw the line as we need to on the page, then we'll notice that there's what looks like a full stop that's blobbed on the top of the A there, and we're going to go straight through it. Now we've also got that and that, and that's what I'm interested in. This is our beginning line and our end line, and of course, so we've got direct hits on all those. Aleph Tav are the first and last letters of the Hebrew alphabet. This means the alpha and the omega, and I just thought it was rather cute. Now you'll also notice that the blue line doesn't actually touch this Aspley dot here. It's on this. It's visibly not in the right place. Now, if you zoom in at a pixel level, you'll notice that this has got a flying saucer kind of behavior. So let's just extend these lines and put a wigwam on the top. Yeah, I'm sorry, but it is, and it's roughly 51 degrees, and that will put us bang on the line. Right, it's not as good at working out exactly where laterally, if you like, that we need to be on the line, but all these points are squeakily accurate in terms of where they need to be radially. And that's because he's been using a pair of compasses. So there we go, in the zone. That's not supposed to be a Masonic symbol. Okay, lots of building work here. So that's very nice, and that's so the purpose of this first puzzle is to define this blue line so that we can move on to the second level of the game. Now I'm going to do this for each of these three just to sort of rub it in. I don't need the page to draw this stuff, right? You need to give me where that point is and where that point is, and then I just run the program. I build my geometric model, my mathematical model, and then I test it, and it works. Now there is a caveat here that the sums, the geometry reckons that this should finish here, and it doesn't. It finishes there. And this explains an anomaly that we've got in that we've two frames of reference. We've got the radial, the circular frame of reference on here. Everything that's actually within the circle is so accurate. But we're going to do loads of stuff with a square in a minute, and there's loads of stuff that's absolutely bang on accurate to do with the square if you're in the square. It's only when you've got these hybrid points that we have an issue, and this 9 dot here is a hybrid point that, whilst it has a purpose in that it's supposed to be at the apex of the phi triangle, it also needs to be at the base of what will be a tau cross ultimately, but it needs to be in line with the serifs of the letter I have imprinted, and all this is now solved. So there's our blue line that we've made from puzzle 1, and that one is exactly what's on there, not what's predicted. So we've slight caveat to the everything can be generated, but in principle everything can be generated from this these first 2 dots if they hadn't made them about 1.5 millimeters to 2 millimeters too far apart from each other. So there's our square. Yeah, we've got a square. So we don't have to worry why there isn't a triangle on that lower line, which implies that there ought to be, but there isn't. There's a square instead. Now, if we draw a pyramid there of exactly 51 degrees, and the computer has drawn an exact 51 degrees. I haven't measured that on the end. Obviously I did initially to try and work out what was going on, but the computer's now drawn that. That's exactly where a 51 degree pyramid will end up, and it will end up cutting the serif there and being above the baseline of this. If I drew a baseline there, it would cut through everything. And 51 has 2 properties. The first property is 3 times 17, but the other property is that it's very near to the angle of a certain building in Egypt, and so because 3 times 17 is so nice, we haven't really grasped everything to do with the rational numbers, and drawing exactly what the pyramid angle is would be a pain in the neck in any case. 51 is a nice angle to donate for that build down. So moving on from this pyramid, I now want to draw equilateral triangles from here. So I've got 30 degrees exactly until I hit that, and then bounce off and go at another 30 degrees from the horizontal up to there. And it just so happens that they hit the S's just about in the middle. And this one is exact. This S is slightly out. And it goes down to the 6, and there's our 6 again, and that's why the 6 is exactly there. And as you can see, it's perfectly on the circle, but it's also perfectly on the central line of the square, which is a little bit astonishing. They're so accurate. So there you go, bullseye. And then we've got a third equilateral triangle, which forms the centre line of Shakespeare's, and then these lines just happen to go straight through the centre of these S's. So that's good, isn't it? These lines get used, these two lines and these two lines are going to get used for something else in a moment. So we've got obviously 3 circles. We've got 3 regular equal-sided polygons. So that's hardly surprising. We can now start drawing pentagrams. So that's as big a pentagram as you can fit in that square and sitting on the bottom. And it just so happens that it hits this A really rather nicely, and it's actually extremely nice because when you fill this line in, that's another golden triangle. It goes up, down both sides of it. That's quite odd. And it also hits this R, which had been noted before, perfectly. So that's the first of our 3 pentagrams. The second of our 3 pentagrams is defined, and it is defined as touching these upper triangles and also touching this lower triangle, and thus forming a perfect centre line through the sonnets. And again, this has been put as kind of, well, it's just page design. The sonnets is not it's not equidistant between these 2 lines. The base lines aren't equidistant or anything. How did I just happen to end up bang on a pentagram that fitted into those? Now the last of the 3 pentagrams is, well, I say it's defined as the horizontal being on the baseline, and then if you draw a pentagram as such from the top of the square, the feet will define the baseline of sonnets. Now there's a caveat on this, that I don't actually have the baseline of Shakespeare's. What I've got is the centre line and not quite the top. So when I reflect at the top of that A, I'll end up over the feet of the A, which isn't where I want to be. So I've had to fudge that, and there's a variable in my program called dot size, which is just a number that will take me 23 pixels down here, and that will work. I don't like that, but it's not something you need to worry about too much, unless you'd like to help me try and find what relationship this side is to everything else. But we've now got, so I lied in the last one. I said that this was defined. It was never defined as on that. It was defined previously. I said it was defined as intersecting this middle-sized, this mummy pentagram. If it was, it would be even smaller than it needs to be. What it was defined previously was on the line that runs across the top of the pyramid, but again, that's not good. That doesn't give us the baseline, and I want the baseline for something in a little moment. So I needed to fix that, and so now we've got lovely 3 pentagrams. I mean, it's not surprising that as they're all centered that they kind of look nice like that because they're going to have lines that are obviously parallel, but it's still nice. And so we've obviously got 3 more circles that I've roughly drawn on there. As I say, everything that you see is machine generated, but these circles and animations that I stick on are not. They aren't accurate, but the lines that I'm drawing on are these thin lines. They've all been done with a machine. So that's okay, but we've only got 1 square, and we need to find 2 more. Now, with all these pentagrams that we've just drawn, it was pretty obvious that we should stick that on there and talk about him. And it was not Ray, but Jay Hall Carpenter, who's been my buddy in these final laps, who noticed that the O here, O for Oxford, looks like it might be in a quadrant on this side. So the pair of us spent some time trying to work out where that is, and the computer's frozen again, so I'll have to clip this. There we go. So yeah, it was noticed that that by J, that is that O is in the corner. So let's put the O in there, and I'm going to draw. That's fairly arbitrary. I mean, it's not. It's exactly a quarter of the width, but we just put in the star on there just to rub it in. I mean, it's situated exactly on the ascender line of Sonnets, and it's exactly 1/4 of the width of this, or half of the width of the square that's going to appear now. So it turns out that the centre line of Shakespeare's and the centre line of Neue Before are exactly half the distance of the square. So yes, okay, it's just an 8-page design, is it? So, and the T, and this was predicted, I've got documentary evidence of that, that, yeah, the serifs, the ends of this T is going to be cut by the diagonals once we'd worked out where the square should be. I mean, we had to try and be mucking around underneath there and stuff, and arguing about whether or not square is a square, squares are squares. So we've got our 3 squares, 1, 2, and 3. So isn't that fantastic? Now, with this T here indicating a tau cross, I'm going to draw a tau cross that's going to be just on the inside of this letter I, which stands for Jesus, and it's going to go directly onto the 9, and that's why the 9 is a squeaky bit to the right, because we're in the square frame of reference, and the square is relative to the circle contracted a little bit. So that's why that has happened. I'm rather pleased to have worked all that out now. So that's good. So we've got a really nice tau cross, and we've also got this cross, which the bar of this, the horizontal of this cross, has high geometric value. It's the upper side of these 2 smaller squares. It's also the upper side of the larger of the equilateral triangles, and it's the axis of the other 2 of them. And then this line is obviously the centre of everything. So it has high geometric value. What makes it so sacred is for the scholarly to determine. So that's the end of the second puzzle. These 2 crosses are taking us into the third puzzle. So again, the computer has frozen. There we go. So again, for the purposes of just trying to drill home that this is all. Somebody mentioned CAD. This is all CAD. All you have to tell me is where these 2 points are at the bottom of the square. I know about 51. You don't need to tell me 51. All I need are these 2 points and go. Right, we do this, and that gives us the baseline and a few other ones. Construction lines. So that gives me the baseline and centre line of all 3 lines: Shakespeare's sonnets and Neuer. So that's good. So let's just focus on these 2 crosses that we've got, and they both point down to the bottom, and we know that those are 2 radial points, two circular points. So let's put the circle back, and in the beginning we have the line discovered by Green, and then effectively in the end we have Alexander Waugh, who I think fairly quickly on seeing this, armed with the phrase "by God and De Vere," which is in twice on the cryptography. On the next page, we have "by God and De Vere." So he was quite pleased with himself at that, I'm sure. I would have been. Now, Waugh then discovered that if you draw a line from the 9 dot through the centre, it will end up on the P. Now, Waugh will draw that so that it goes through the stem of the P, and he's correct to do that. I believe it is supposed to do that. If this was stretched out the 2 millimeters it needs to be, this would be about 1 millimeter further across, and it would fit, and we wouldn't cut the N either. I don't think the cutting of the N serif there, which is normally something which I go, ooh, I think that's false. But either way, it doesn't, for the purposes of just, nobody's really going to notice. But there have been arguments about, it doesn't really go through the middle. It goes, I've defined that as going through the middle. It goes through the middle. So there's a Cairo. Now also, if we then put Green's construction line back across here, we now get a Petrine cross. We've now got our 3 crosses. So the last puzzle is the 3 crosses. So I'm rather pleased at that. And now we've got a 6 and we've got a 9, and both those are very hermetic numbers. The Masons like both those numbers. Now, if with another, well, on the other page, on the next page, it says South Transept. It says Westminster Abbey, South Cross Isle. So let's just roughly just plonk the columns that keep the South Transept from falling down on there, and there are 4 bays, if you like, in there, and we look at the last one, and that point there was the altar of St Glade's Chapel. I'll have you know, my scholars inform me. So that's interesting, isn't it? Now, we're missing a circle. We've got a second circle, which is this G dot, which I'll come to in a minute, because that dot is a glyph. But we're missing something, aren't we? And anybody that's really into this knows what we're missing. We're missing D's monad. Where on earth could that be? Well, I'm convinced that it should be on this line, pointing at the altar of St Glade's Chapel. So just plonk it on there roughly, and then I'm going to scale it and get it, move it across so that it's on that line there, because we're not using that yet, so that seemed like a reasonable thing to drag into this, and we get a nicely roughly sized one, that's proportionately that's okay, but I was hoping that we'd go through the cut on the R, and we haven't done. So I need to build a monad generator so that I can have these squeakily clean. But I think this diagram looks as though it's probably reasonably right. So I can't really justify it. So I don't really want to put it on the diagram proper. But it'll. Yeah, if you can justify that, you can find it somewhere else. I'm personally convinced that the monad must be in here. Now you may be wondering where our pyramid is, because we need a pyramid on each of these, and oh look, we've got a triangle there. And yes, that's I mean, as best as I can. That is a triangle. I didn't get a subsequent response back from the British Library. They responded to me saying what we've got is, online, and I said I want to get someone in there with a proper camera, and they haven't come back to me, so I'm going to have to escalate that out of various channels to do that with. Here's our G dot. Again, this one I've not ignored that. Well, I have no explanation for it, but I've noted that it's fashioned off on that side. But we'll ignore that for now. It's just a circle. So that's our third circle, assuming that the second circle is the monad that we haven't really justified as yet. That triangle at the bottom there is can be treated as a delta. There's the D in the middle that's got both these crosses through it. So that's delta, and because D signs his name delta dot, and that dot is the beginning and the end of these three puzzles. And there you go. That's my interpretation of how you're supposed to look at this. Just to rub it in again, all the lines that you've seen have been drawn by a machine. The only caveats to that are that when moving to the square reference, we have to then use the one that's on the page, not the one that was generated. I do so wish they'd got that bang on, but it's been a little chase for me. The only other caveat was that I haven't managed to find an entirely pleasant solution for the small pentagram, because I need it drawn without looking at the page, right, which is the reason for showing you all that. And just to go back, and we've got all this here, and this here in particular, to Alan Green and his fantastic discovery of these three triangles. We would not be here if it were not for Alan Green's inquisition and for his diligence and his insistence on finding numbers in here. And he found that this was the tangent, this had a tangent value of pi, and then found these others. Now, unfortunately, Alan just then extrapolated that and carried on, and I am regretfully refuting everything else that he's said about this. I've gone through all of it, including all the really complicated stuff to do with all these, the sum of the angles and stuff on all these triangles, etc., etc. I coded all that up in a computer. I've looked at lots of other stuff. But I do recommend that you have a good look at him. He's good fun. His videos are. But go easy on the maths. That stuff doesn't add up, unfortunately. There we go. And so we're back to this guy. This is the Ashbourne portrait. I'm convinced I'm staring into De Vere's eyes. And of course, these two lines for 300 years and more were used as a standard device to indicate anonymity. You might say by a Bostonian or something like that in there, or you might just leave them blank. Well, let's fill it in with Edward De Vere. My work on this page, I think, is coming to a close, and I will return to page 2 to at least collate what I've seen. But that's it.